Hello, this is John Wallace, Senior Editor at LASER World, and I'm at LASER World of Photonics 2015 in Munich. And I'm at the Fraunhofer IST booth with Christoph Gerhard, who is a researcher there, and he's going to tell us a little bit about his research into laser plasma hybrid microstructuring of glass. So could you tell us a little bit about the process?
Well, actually, you know that microstructuring of glass is a very interesting issue for a number of applications. The main challenging task, in my opinion, is that glasses are usually transparent to laser radiation. So there are several techniques in hand in order to overcome this restriction, such as laser-induced backside wet etching or whatever, what have you. And our approach was to use an atmospheric pressure plasma to combine it with laser irradiation. And in this case, we use several different mechanisms and interactions. Maybe I could show it here. As you can see, this is a atmospheric pressure plasma. You can see the glass down here and a laser-induced plasma. So you have both. And the plasma actually affects a modification of the optical properties of glass. So the energy of the incoming laser beam is coupled much better into the surface, thus reducing the energy threshold required for ablation by a factor of approximately 5. And due to this reduction in ablation threshold, we can avoid, or let's say decrease, the thermal impact on the glass, resulting in a much better machining quality.
And I'd like to find out more about the process, but first, could you tell me about some of the uses, some of the optics you would be creating using this process?
Well, it could be micro lenses for fiber coupling, it could be micro lens arrays for beam homogenizing, it could be Bragg gratings for spectrometers or whatever. All cases in micro optics.
And what is the resolution, the lateral resolution of the optics you create?
Well, it depends on the laser irradiation you use and the optics you use for focusing the laser. But it could be down to some tens of microns.
Oh, okay.
Yeah.
And there is a gas hitting the substrate too, and what would that gas be?
It depends on the mechanism we want to achieve. We want the plasma to produce on the surface. It could be nitrogen or hydrogen containing working gases or argon, depending on whether you want to use plasma chemical or plasma physical interactions.
And what do you see coming down the road? What future research or commercialization, or what do you see?
Well, I guess it has a high potential due to this decrease in energy threshold. So talking about cost and energy efficient microstructuring of glasses, I guess this technique has a high potential for any case, for any question in microstructuring of optical components.
And may ultimately be commercialized?
I hope so, yeah.
Okay. Well, thank you very much, Christoph.
You're welcome. Okay. Thank you.